Good morning, everyone. I am so glad to see so many of you have already joined. It's wonderful to note. Probably we will wait for a minute more for others also to join so that we can start. All right. So once again, good morning, everyone. I'm very pleased to be part of this conversation today. What we will do today, we will spend more on how convolution happens so in the network models. So I will also take you through very briefly what has transpired yesterday to get all of us up to the speed. Then we will look at briefly Python programming, which we will be using, and we will also look at the libraries that will help the network models with a lot of ease. Thank you so much, Ms. Rashikar, for the compliment. So I'll just move to the next one. All right. So yesterday when we started the discussion, we said essentially when we have, let's say, create new one. So whenever we are trying to get machine to learn things, there are 3 steps involved. So that is where we are talking about machine learning. So while machine also is attempting to mimic cognitive abilities of individuals or cognitive intelligence of humans, the 3 things that it broadly does is it recognizes, it predicts, recognizes different objects, entities, it predicts what is the likely future state or what is an unknown state, and third one, it takes actions. Now again, for these three different things, the machine learning model has three broad steps involved. First one being pattern identification. It will try and look at relationship between what data we have, we call it as normally input variables, and the output variable. Let's say we are trying to predict whether a particular animal is a dog or not. So this dog or not becomes a binomial classification. Now in this output variable being this, what are the input variables that will help? Let's say we are talking about an image, and image is now converted into some sort of pixel, or we will talk about not even image, it's just certain features in terms of number of legs and the size of the object, then the weight of the objects and the skin texture of the object, color of the object, and so on, mouth shape, etc. These are different input variables. Now when we have these input variables, by looking at this, we need to predict what animal is that. Now this pattern identification, there are so many animals. Let's say here it is dog or not, which means binomial. Let's say you have dog, cat, tiger, so on and so forth, the different animals, 10 different animals in the output variable. Then we call it as multi-class classification or multinomial classification. So I will put it as multi-class classification. Now this relationship between those input parameters and output parameter is called as pattern identification. Now there are different methods in which you can identify the pattern, and it is also determined by what kind of variable is your output variable. If it is a continuous value, something like profit that a company would earn, then you will use a fairly linear equation to try. So linear equation will have a linear relationship between x value, which is input, and y value. So linear relationship is something like this, and where this is being x and this is being y. Now there are also non-linear relations. In the case of dog, yes or no, you only have yes or no. So probably something like a sigmoid curve we will have. Broadly you consider this. So this is a non-linear relation between x and y. So you will have some sort of a threshold and say this is 0 till here, and from here it is 1. So it's a probabilistic estimation, you can say, or likelihood of a particular y given a kind of x is so and so. So this process or this method is called a pattern identification method. So there are many different models or equations or algorithms so that will determine some sort of a pattern between input and output. The second step that we have, this I will say as a first step in the machine learning model step 1. And now if I have to look at the second step, we said it is error determination aspect. Second is error determination, because whenever you are attempting to look at the pattern between input and output, what we are looking at is we make some assumptions here. And now let's take a quick example of again the linear equation. It is mx plus c, m being the slope, or we spoke about yesterday w, and c is some constant, or b. So this intercept we spoke about yesterday, we say we will call it as some sort of a bias to bring the relation between x and y we have introduced. Now w and b are the parameters that are establishing the relationship between these two. Initially when you do not know what exactly is the relation, you make certain assumptions. We call it as initializers here. Maybe you will keep w as 1, b as 1, or b as 0, better, and think that y is equal to 1x or mx is 1x. This is the linear relation you initially start with. However, the value that you get from here, this using this method is, let's say we call it as y hat, is what you predicted value. Now you compare against the actual value. Actual ground truth value is, let's say, y, and what you are mentioning is y hat. What is the difference between these two becomes the error. Now this is the error, or we have to determine this error using a method. Since we will not have just one record, you will have innumerable records or innumerable objects or data points that you will have to look at all of this data, and if you keep simply sigma here, what would happen is that the negative values over here sometimes values sometimes predicted is higher, sometimes is actual is higher, so net can become 0. So therefore we use typically sum of square of errors. So you keep a square so that the error value 1 increases, and more importantly the error any negatives will get addressed. So why we should use square and why not modulus can be another thought. The aim of this model is the pattern that you identify, it has to be close to accurate. So the predictability of it has to be very, very close to accurate. So if you square the error, you will attempt to minimize it, and therefore when you try to bring it to 0, which is only good, so you will have y and y hat coming close to near equal. So the third thing is by now you are fully familiar, is error rectification method. Now error rectification, there are many ways we can do the rectifying this error, the difference between y and y minus y hat. Yesterday I spoke about gradient descent model, saying that if you this is the error, say j theta or some sort of error value, and now the error theta value, let's say, is here, the error value theta. Now you have to slowly reduce this error value, and why slowly, why not suddenly jump here, because sometimes when you are jumping you could completely miss and go away, you will miss the bottommost part of error. You will also notice that it is not touching the 0, this being the 0 value, because in real life it is very very uncommon to really get a complete 0 where the error is absolute 0. I have not come across one. So now look at this error rectification in a gradient. Gradient means it is coming down the hill or valley kind of thing, you are descending slowly. Now to descend this, so this particular curve, this is a curve, so we do not have a linear to look at the slope, so you therefore look at a cos theta. I will keep it like this. A small change here will bring some bit of near straight line here, so therefore for this small change of delta we will try and compute that value. So what value w is here, we will try and alter the w value and b value by getting the derivative of w. So we will get the derivative of w given the error that we have. So we have the error, so what is the w value? So once we get this value through this, then the new w that we could compute as the old w is nothing but the slope, which is the parameter, right, that we have made an assumption. So the old w minus a lambda function I spoke yesterday is some sort of a learning rate. So n in network models it's called n. Network models are popularly known as deep learning models, and the lambda or lambda function, which is the learning rate, at what step I have to come down into the derivative of the error over the weight. What is the derivative for the weight? So once you compute these w and b values, let's say, you again go back to the first step of pattern identification, and then now earlier you had an assumption, now you have a new values, you use this value and try here, then go and determine the error, what is the error, and then come back and rectify the error. These three steps in a iterative fashion we will work on it, and we say that every time you complete a cycle it is an epoch. We looked at this as a base model. Then we went into the next step of so then we said now there are a couple of things that are important in pattern identification, or in the network models. Let me speak about in the network models, when all the input values are kept in the form of a circular cells and the output value is also a cell. Now the output value has two different things. One, it will sum up it will perceive the data, so it will perceive the data. Two, it will process the data. So there are two pieces in the output value here, and it is similar to a biological neuron, so therefore we call this as artificial neuron. So biological neuron in our brain also perceives the data and processes the data. Now there are these two things that happen. In addition, the network models create I will try and move to another thing. So now there will not be any disturbance. Now move to the Bluetooth. Yeah, so the network models also have hidden layers here. Now, so the advantage with the hidden layers is that you will have more number of parameters, W and B values are more. Otherwise, what would have happened in the absence of these hidden layer, you have all these X values directly connected to your output value, and then so many number of weights you would have had, W1, 2, 3, and maybe there will be one bias. So that's how you would have had, and you had only 4 parameters to play around. Now with the hidden layer that's introduced in the network models, you will have all of these input values connected to each of the cells within the hidden layer. So therefore you will have, we call this as a dense network, where each one of them is connected to all the other in a sequential manner. This is a sequential method. So we have created that hidden layer, and every cell in the hidden layer is also again is a neuron, which means it will take the perceive the data sigma values and then quash the data and bring some amount of non-linearity into it. This is where we spoke about, okay, what is this processing happening and why this processing need to happen. So normal processing would have been, you will say, look, everything is a linear relationship, so therefore y is equal to, y is the output here, y or output is equal to mx, or it is nothing but mx is nothing but sigma of all these values. So where you will have a bias term here, you can keep for everything there is a bias term, or you can have a same bias, let's say, to begin with, and you have this bias term that gets created. Now this y is equal to mx plus c you will create, or better it, you just say y is equal to mx. So there is x value with some ratio, if you multiply then you get y value. So that's how the relationship. Now normally you will require to quash it to some bit of let's say you have these negative values here, any negative value here or any negative value here. What happens is when you do the mx where this mx is now nothing but sigma, because xi is there and mi is there, or so then it can become 0. Your y value, output value, can come close to 0 if there are positives and negatives. So therefore you can bring some amount of non-linearity into this output, and the very popular non-linearities are logistic regression driven, which is sigmoid curve. So what sigmoid curve will do is make this linear data, which has the limits from minus infinity to infinity. It will bring this down to 0 to 1. So this is what get quashed here. This is how we can present that sigmoid curve. This is where we also discussed that there are alternate methods. This is sigmoid curve. Then there is an alternate method of this squashing. This squashing or bringing non-linearity can be done, and this term is called activation function. That is what activates. And we spoke about rectified linear unit. Whatever is the linear unit that we had, so the linear unit was always like this. So if there is a negative value, the linear unit between any x values negatives were there, it would have just been like this. So even the y value also, for a given x, the y value would have also been y here. The This is a minus term of x and this is minus term of y, and the line would have gone down like this. So what rectification is happening to this linear unit in ReLU is, it will nullify this entire part and bring it down to 0. So anything less than 0 will be brought down to infinity. So when this r or x value has minus infinity to infinity, then the y value typically is one of the ways in which it is presented is r value or y value will be 0 to infinity. So this is one activation function that we saw yesterday. Then there is another activation function we said, slightly modified rectified linear unit. It is called leaky ReLU. In the leaky ReLU, what happens is you have this, I will probably, since I'm going to share this as is, in the leaky ReLU, so what it happens is the zeros, if there are high negative values, to avoid losing the data, we will bring some sort of, we will allow a portion of x. So earlier it was x value is presented as x comma x on both the sides. Now we will say maybe 0.1 x comma x is what you will get for y values. So the y values is limited to 0.1x. So what happens is only 1/10 of it is the moment. So this is where we are saying leaky ReLU, and the remaining things again it will remain as straight linearity here. You have leaky ReLU, of course parametric ReLU is also there. Now these are different things we spoke. Then finally we also spoke about an activation function which is softmax. Whenever you have, so for a binomial distribution, particularly the last neuron that we have, which is an output neuron. If you are working with a multi-class classification problem where you have, we spoke about cipher 10, where there are 10 different classes of cat, car, dog, etc., or aeroplane, frog, cat was not there, I think, frog, etc. If it is multi-class classification, then the sigmoid curve will not work. So you need to use a multinomial logistic regression model or multinomial classification model, popularly known as Softmax. In the Softmax, it allows you to provide that different classes, and we have seen the equation yesterday. So these are all different activation functions. Then we came to what are the cost functions that we should see. Our cost functions are nothing but our error determination methods. So while sum of square of errors will work in case of so linear data, if it is the binomial classification, what do you do? So then we looked at the other model of uh, entropy. We looked at cross entropy. So in the cross entropy, we have getting the data of minus y, which is the value minus y into log of y hat is the prediction, into minus 1 minus y into log of 1 minus y hat. So this we have looked at how we will derive at this and so on yesterday in detail. So this is the error determination function. So once we have the error determined, in the case of, let's say we were looking at somewhere, yeah, in the case of this, and we have error determined here and there is an error, then you will do a back propagation for error rectification. For error rectification, you went behind and step by step you have gone. So when you are done back propagation, we just spoke about gradient descent model. We have used that. And another popular, very popular model of error rectification is Adam model. Now, the next step from here, with this model is called fully connected layer. Because each input values are connected to each neuron in this next layer, and after that everything is connected to another next layer and so on. So these are also called as single layer perceptrons when the input is directly connected to output. When you have any hidden layer, then it is called multi-layer perceptron, because more than one layer. So final output is one layer where you have the neuron. If you keep even one hidden layer, then you have more than one layer. So you can call it as multi-layer perceptrons. And of course, if you have more than, these are two layers, one hidden layer and one output layer. If you have five or more hidden and output layers together, five or more layers, then it is called deep neural network. So it is then deep neural network where the complexity is introduced. Now, one important aspect I will share before I go into the programming is, if you connect all the input values to next level all neurons and then next level all, while it becomes dense, sometimes it can do overfitting. It will learn too much into the existing trained data set, and probably it may not yield a better result for new data. So therefore, a method in which you can handle it is, you can drop some connections here and say this connection I will drop, this connection I will drop, this connection I will drop. So randomly you drop some connections of, let's say 20% or so you can drop, and thereby hope that it is not too much overfit into the training data alone. So just to refresh, what is training and test we spoke about, to help machine to learn. For learning purpose, you give the entire training data. So if you have some 100 records, 100 objects, you train the machine only with 80 objects and keep your remaining 20 with you, so that once you train your model, it will generate you those parameters W and B. Then you can apply those parameters on your test cases, 20 cases. Then you say how accurate the model is. All right, with this backdrop, we will, I said we will use Python programming language, and I'm assuming you are all at least somewhat familiar with it. So I'm going to very quickly take you through some of the basic stuff of Python, and then we will go to the neural network code. So this is my terminal. I'm working on the Mac operating system. So some of the look and feel will be different. Now I also created a virtual machine in my system so that I don't have to clog my machine with all the libraries that I download, which is called AI training. Now I am there. In this I have all the libraries downloaded. We can try it later, test it once again later. Jupyter Notebook, going and clicking. So this is one way of going and accessing Jupyter Notebook. Another way is, let me also check what is the speed so that we don't get a surprise later. So yeah, it's health. So another way is that you go to the you go to Anaconda and direct at the Anaconda, and this is the best practice. You have to install Anaconda, and there you will have Jupyter. Go and click that Jupyter, you will have access. Another way is just directly go to the terminal and type Jupyter Notebook, and it will give you. So here, if you notice, we typed here, and it has opened up the file. Now, I'll quickly share some of the basic stuff of data types, data structure, how the data, what are different types of data that Python programming language remembers and stores, and how the data can be structured. We'll also look at two important libraries called Numpy and Pandas, all of it in under 15 minutes we have to do. Let me quickly go there. All right. I have done. So some of you, I think, also participated in the previous faculty development program organized. So uh, probably a basic code I will show. So this is the window where this is the Jupyter window where you then have access to your root root folder. You can go and check wherever you have the Python code is available. You will notice that I have IPNY as the extension. IPN NBY, it should be. What is this? IPYNB. Sorry, IPYNB. So what this means is the Python notebook. So you also have .py. If you are running it from a code editor, a simple editor, then you have a .py file. For example, Atom I use as a code editor here. A code editor here, I can type the code, go to terminal and execute it. The advantage with the notebook of Jupyter is I can run the line-wise code execution and see the result then and there. So let me show you some basic commands. Now the Jupyter on the top, you have file, edit, view, insert. Then you can do the run, or also there are some shortcut buttons like shift enter. So to run a line of code, you can choose keep markdown as well as heading and so on. So just to share with you the titles, here you have markdown and the code. Markdown is it doesn't run the code, and the code lines it will run. Heading of course will give you a big sized font by default, otherwise in markdown also you can change. Plus will give you one line extra like this. So each one is a line that you see. So cross mark you have and saving. So whenever you try new one, this is where the file name is saved. So here it is on the top. The file name is saved. You can change it. Wherever you opened it from that folder, it automatically saves. Now you have in the new, you have to press Python 3 for you to run this. Alright, so let's look at the basic Python commands. It is very close to English language. So you can say A, B, C, D and give some values. You don't need to define what is the data type of a particular value. It will automatically search and determine, okay, yeah, 99 is there, this is an integer, and will take care. These are the integer, float with the decimals, strings you have where you can keep multiple characters together, and character it allows, and boolean it allows. Boolean is true and false. Now the both character and string allows both two quotes and single quote. You have the result. Now here I say import numpy as np, pandas as pd. We will talk about what is the numpy library. This is an excellent library where all the scientific mathematics, mathematical details are included, all arrays, so matrix multiplication, so you have innumerable things. It also reads a Numpy file it can upload. Now Pandas on the other hand has tables. It can take the tables, load the tables, save the tables, and manipulate the tables. So tables in Python we call it as a data frame. Basically, what is a table? You have both x-axis and y-axis both. So you can keep attributes here of a given object. The object is, let's say, of dog. So the object is dog, which we keep in the y value. And for this, what are the attributes you are filling? It's number of legs. All of this become your attribute. So this one thing is called an object here. Now this data you can present in a two-dimensional form using pandas, and that is called data frame. Now we have given from ipython.core interactive shell. You have to, if you can use this AST node interactivity is all, then it will print you all the things that are required to be executed in a cell. Otherwise, if this is not mentioned as all, by default it will only print the last term. So that's how you will notice in all these practice sessions, and I hope some of you at least have practiced yesterday when I shared this document through Blsckbuck Engineers. Then we can check what are the types of these data here. We can do the addition directly here. B and C addition is not done. If you notice, C is, what is the data type of C? It is string. So A and B it has taken, yeah, integer and float and automatically did, but B and C it could not do. Now similarly C and D, if you look at both, one is string and another is character, so it did not mind. Plus it has already considered as appending the data and has done. So on and so forth. So those mathematical operations are here, what works and what does not work here. Now let me move to the next one, which is yeah, string. We will look at then. Now, strings you can keep in a single quote, double quote, and triple quote. So that is based on your convenience. So, and it will still take all the strings data. Then if you delete the strings, del will delete the string. So it is so closer to text one. You can keep it in the tuple. We will talk about other details, and then you can print that and it will show you Python program and so on. So you can ask for what is the type of the text and it will give you string. So what is the length of the string, you can ask for it, and you can do the indexing and slicing. There are more details that are available in this document for you to look at this. You can always ask for, refer the index of the string so that you can, it will call the data. So now let us see the next step of lists. So this is another data structure. So type of data structure where you can store the data. At a high level to share, list is ordered data structure where it is changeable. Tuple is ordered but unchangeable. You cannot mute this. Set is unordered. You don't have a reference of index, etc. So there is no order into it. Dictionary is unordered, but it is indexed. So you can call through an index a particular cell and still get it. Always an index is created, and it is also mutable. So there is some degree of flexibility you have, depending on, if you don't want your data to be mutable at all, then you use tuple vis-a-vis dictionary you use if you want to make a reference to the index and call the data. So if you have to look at, let's say, the text, you can call like this and it will print exactly. The space also is printed here, you will notice. Now if you want to convert string into list method, what you can do is you can do just a split. This is a method split, so it will convert a string into now it will split the data. Now another case that we can see is of course shift tab for checking possible parameters in a function. So if you have, let's say, a split, and you can check what are the possible parameters that it allows, we can check here. Now split, I will try. Now, okay, we'll check about that again. And indexing, let's say indexing is, you can call the data elements from their position, it is first element or last element or third element. You can call that data, and you will notice here list allowed different data types. It need not be same data type that you can see. And when I say my list and give me the from the first element, always the data is referred from the 0th element here. So 0, 1, 2, 3, 4. So in the last one is -1. You will notice here -1, which means the last element. You can also call like that. Or this is 0 and this is 1, 2, 3, 4, 5, 6. So 6 you call or -1 you call, still it will give you the same answer. So this is the indexing part that we can look at. I will probably share another aspect here. You can also call the data from beginning to the end. So that is also possible. You will saying from here again provide me till there. So it will give you the entire data of it. The next one, you can also append the data. So I think in the first one also we looked at appending the data. So there, for example, I can append these data into the other elements. I can add them, join them in different ways as a together as one, or separate strings also I can append the data. For example, in this case, you will notice that you have the DL is appended here, and yeah, and the fourth element here, we have said fourth element we should have the DL appended. All right. So while this is list, we will also look at, let's say, dictionary and tuple and sets. So tuple, so it is immutable, we say, and once you create, uh, so by default, if you call the data, uh, it is considered as a tuple. So you will notice this output has come in this shape. So what is TUP data type, and it already shows it's a tuple. So you can provide different data types in the tuple. It is giving answer. You can refer to the order is the index. So refer to the first index. What do I have? It will provide you the data and the total, and you can convert a list, convert a tuple into the list. So you can convert. So this is the tuple, and you put it in the list, and it has now become. These are the values, and you will suddenly notice there is a square bracket. Square bracket indicates this is a list, and regular braces indicate it is a tuple. So now we will look at sets. So in the set, you do not have an order in the data, which is the key thing that you can have. So you have entered this data in the set, and you put it in the list here, and you have the data. It has come using the alphabetic order it has put together. So similarly here also again the data is changed from false, and then data has moved to other things. Now, so these are different things. So how sets don't support indexing, it is not there. Now, the very useful for us is dictionaries. We use, in fact, dictionaries is the method through which data frames are created, where you can create an index, so key 1, and the first index is value 1, second index is value 2, key 3 is value 3, and keys provide the variable titles, and then you can also have the data fed into it along with the key. Now this is one value. Name is the key, and so this data is Virat, Rohit, Dhoni are the values in this key. So which means it is more like a first column. First column is name, and the attributes of this or values of this attribute name is Virat, Rohit, and Dhoni. Similarly, you created another variable or another attribute, and then you have passed in a list the data into it. Similarly, now if you call this employee date, you will suddenly notice name and all of these details, age, all of these details, and you can convert this into a table format where these are the index. You can keep these index as the variable titles and this as each object, and it will provide, it will take care. Since you have given role as cricketers, it will take care for all of them as repeatedly cricketers as data. So that's how you can go into the dictionaries. Now I'll not go to if and for loops. I'm assuming these methods are similar in all. Instead, I will focus on functions part. A couple of lines about functionality. Numpy is NumPy and Pandas are the most important libraries that you have. If you don't use NumPy, then you can use import math. However, you will have to do a lot of coding by yourselves. Hopefully, you have ran this code that I shared of yesterday on backpropagation. And in the exercise, we will also convert the 10 into 10,000 to see how it runs just after this. All right, NumPy. So today, by the way, as I shared in the beginning of the session, that we will have the break after at 11:50, and then we will start the session 11:10, 11:15. We will take the break, and then another break is at 12:20 or so, and 12:20, 12:30, and that's where we will directly take. After 2 minutes, I will answer all the Q&A, all the questions that are arising, whatever I'm familiar with. Okay, NumPy is an array that we have, and you can place this value in an alias term instead of just saying import NumPy and call NumPy everywhere, NumPy dot so and so. Instead, you can create an alias for it and say as NP, and you can call NP. So you can call this as version after you import. Now, if you notice, I'm saying array 1D, I'll create np.array. It has an array, and then I'm passing a list in it. So I have an array with 6 values now in it, and I can run this array. Similarly, I can ask for what is the data type of array. It will say this is of NumPy's ND array. ND array is the type of data within the NumPy. Similarly, I can do the multiple values. I can give multiple sets of data within it. It will take the data and create a matrix or three-dimensional array I can get, two-dimensional array I can get. Now here this example, if you notice, one-dimensional array is a single dimension. All the values are provided. However, you can have a two-dimensional array. You can provide this value within this two separate braces. It will automatically take it as the multiple list. When you create with this comma separated, then it will take it as a second array. Similarly, you can use these braces to say these two are one data and these two as another data. So you can, that it creates, you have those multiple array types it provides you. Now the properties, of course, you can say, you can create shape is the most important in the array for us in the CNN, because we have to get our shape into whatever are the rows and columns numbers, and then whether it is a grayscale or RGB, how many channels are there. So shape becomes extremely important. You can read the dimensions of it by saying dot and dim. So, and then what is the data type, size in bytes, these are other things. However, shape is most important for us. Shape, if you notice, 2 by 3 is the shape that we have. Now, of course, there are some exercises you can look at it. Now I'll go to pandas. Yeah, in pandas, if you look at, of course, I have also imported the NumPy here. If I have to, here I have some bit of computation. I'm taking one particular file. We'll share that with you right away. In the dictionary, I'm calling it as a country is the index or the variable name, and then there is a set, data set that has been pushed with 6 different values. So capital, area, population. So you will have these 4 appearing, and the data is filled within it when we call it. So if you look at, see, now pd.data_frame and dictionary. So pd is pandas as pd, and alias is created in this, you call it as dictionary. Then what you had got presented in this form earlier when you called a dictionary, now suddenly it became in a tabular format. And the object number is also provided, object 0, object 1, 2, 3, 4. Earlier you used to, we got the output as this format, a paragraph format. Now you got the output as a tabular format. In fact, data frame, I think it has come in 2008, and that's when suddenly the Python has significantly jumped in terms of adoption, and surpassed even our users status. Data frame was the key to bring about that difference. Until 2008, this was not there, so we were directly working with dictionaries, and it was not easy to proceed with that. All right, so now you can always assign it into some values. You are seeing the index of 0 to 4. This is indexing of the object. So this is the variable type. So you can variable name. So this is the variable label we can call it as. So index is for every object you will have an index. Alright, so you have more details here. You can load the data like this. You can say cars underscore database pd dot read underscore csv. I want to read a comma separated values file and read. So R we keep here in the braces. You can just say car underscore data dot csv. However, this will run only when your file, this Python file and this CSV are in the same folder. So a good practice is always keep your Python file and the data sets in the same folder. If you notice at the bottom here, you will notice here car underscore data underscore CSV. That is the file that I'm talking about. I can call that file and then say, I can just say enter. So I have an error saying that name PD is not defined because I have not ran the import pandas as an alias I'm creating. Now it will run. So there is an asterisk mark. If you have an asterisk mark here, which means it is processing. So now once I read this, I will look at what is the data in this data frame. I can ask for information. I can ask it to describe the data, or I can just say the head. It will give me the top 5 values here. And so yeah, if I say dot head, then I will get only the top 5 values. I will just, and so on. So you will see only top 5 values I've got. You can say dot info and you will get more information. And so these are all different types of data. In this you have, there is an integer, object, float, and so on. You can ask for describe. You can ask for shape, dot shape, and so on and so forth. I think all those explanations are available here for you to go through. I'm assuming now we have some basics are done. While we are using the line-wise code execution, functions are not essential. In reality, functions is the only way. Functions and classes you define in programming for to run better. Let me check if is it buffering or yeah, yeah, I'm still improves. Good. I wanted to make sure that everything is going smooth. All right, so I think the speed is also fine. We will continue the session. Functions are important aspects in the functions and classes. Now, so I can define a function using def, and then so I keep this colon here, and so whatever is the name of the function will give and have an empty parenthesis. I can also pass certain parameters and give some arguments to those parameters so that whenever I call the same execution of what content relevant. Now, when I call greet function, it will say hello world. I say greet user. Now, whatever value I write in the user, it will just print the user. Now, I say greet user is equal to you, and then say greet. Then it will simply say hello you. But this you I change it to greet Mauli. It will then say hello Mauli. For example, we have an authentication service. What we will do at the end is the person name you take and say greet this. So it will automatically, it will then say hi, hello in the chat bot or conversational bot. So you can write a doc string this function. So if you keep this 3, I said either 1 or 2 or 3, it works for you, and you can execute this. So then if I say greet, then it will say it has given me hello you. So what I have mentioned here is a comment only. Now I can also do the addition, multiplication, etc., and the value can be returned. So it can return. So here it will say I return the factor. So the function name I will refer. So here I have directly used this, but if there is a computation, I'm using the term return. This is one change. Then I can also introduce for loops in it, and similar to C language, for in range for I in range 1 to 10, and you keep a colon, and it will run, so on. So we don't have to go into these details right now. However, if you want, I would suggest you strongly to get this familiarity. Now that we have some understanding, let us go and solve yesterday's problem. So yesterday we spoke about, I just want to make sure you are Can anybody type there whether my voice is clear or you want to make any changes in the vision or voice, anything that you want? I see this being good. Now let's look at very quickly yesterday's problem statement and then I will talk about. Yesterday you would have got the neural network. Yeah, would have got this particular file on neural network where we spoke about you have the case of two input values I1, I2 were 0.05 and 0.10. This tabular format data we have converted into these cells and the output value is 0.01, 0.99 where the cancer being there. If the cancer is there with an abnormal cell, then it is 0.99. No cancer, then 0.01. So then we have made some initializers we have taken for weight and bias 0.15, 0.35. I think weight we have taken different values subsequently. So then what we said in a fully connected layer I2 also would connect to 2.1. Now we have introduced a hidden layer. Of course there is a bias. We introduced a hidden layer here and I'll make it slightly bigger so that it is better to view. And here we have made this fully connected data, so where I2 also will then be connected to hidden layer. So before that it is to the output all are connected, then to the hidden layer all are connected. Now you see the weights for all of them we have given different weight values. So here you will notice different weight values and we have gone ahead and did the forward propagation, forward pass. So we went and filled H1 because this is a neuron, you have all the information perception and information processing. It has done both of them and you got all the values of this H1, H2 and O1 and O2, what are the predicted values. So the predicted values then you compared against the existing value and then you have got all of the y minus y hat or the error determination. Then error rectification are all the steps. I think we went at length on these aspects and finally we said we found we have got all the new values W1 to W8 and then when you tried the new error has come from 0.298 to 0.291 after one full iteration. That's called one epoch where all the records, all the objects are seen. Now the error is still there 0.291. So when we run it for 10,000 times here, you will notice that the error, y error is nothing but y minus y hat is plummeted to a small value 0.00003. So this is y minus y hat and we have used here a cross entropy. We used sum of square of errors for the error determination here in this case. So the value has come to the small number and at this point when we fed forward the weights, both all the weights W1 to W8 and the bias 1 and 2, when we have passed it, the y hat values for the first output 1 has come to 0.015. The actual output 1 was 0.01. So very close answer. Similarly, this output 2 was we have got the predicted as 0.984 again as 0.99. I shared this one without any libraries. It is a long code. We will quickly execute that to see what happens. If you have already executed, probably you can share. Or did I close it? Okay. So let me open this again, the Jupyter notebook, and unknowingly I think I closed even the Jupyter notebook. So I'll have to open it. Now let me activate my virtual machine folder. So it will be visible to you now. Now I will call Jupyter notebook. Oh, spelling is wrong. Jupyter. All right. So now I have this Jupyter notebook is open. In this I have this file, I think in the same one where the applications are here. Backprop example. So I put together this example. It is adopted from another professional data scientist online. So here you will notice only two libraries are imported, basic math and random. So it will randomly generate certain values. So it's a long drawn program, but the important is look at there are four classes. One class is neural network. So it will then, it has multiple definitions. and the same thing that we have done using the mathematical derivative, here we have converted that into program. And then we have created a neuron layer, is the second class. Then we have the neuron class that's been defined, which will give different outputs here. This is more critical. And then we then saying yeah, three classes we have created, and now we are calling this as all the functions neural network you can have with hidden layer weights and so on. And we run this, it should it will give you results. So now I am running here for 10 iterations and see what happens. Enter all the W1, W2. You will notice that, for example, in the class neural network, in the initializer, you will see self.hidden underscore layer is, we have initialized, we have assigned certain values, and then we go and give these values here. So you will also notice feed forward, updating weights after each training case. How do I update the weights after each training case? Output neuron deltas that are created. So you can do this, whatever or the derivatives that we have, all of this is converted into a mathematical representation. So the error E for ZZ is here, and so on. Now I will run this file to make sure shift enter we can do, and then the files run. And when I run this, you will notice the error is 0.291 initially, and it has come after 10th in the 10th iteration 0.220. Let me keep it as 100,000, 10,000. We will see now the total error. So the 10,000 times it is running. So all of the calculations that we did yesterday for 1 hour or so, we have done in a split of a second, all of it. Last error is very, very, very small. So it is really small, 0.00035. So it's a really small data, and at this stage the values are very close to the real y minus y hat. The error is very, very small, which is what we wanted to understand. Now, while this is the backpropagation, I think it is important for us to look at now how a neural network runs. So when we are running it, a couple of important aspects that we need to be familiar with is one, within the Python, there are few libraries which are more like heavy APIs. One of them is TensorFlow. TensorFlow is from Google, and of course you also have, there are other ones like PyTorch and Theano. Theano is now stopped. This Canadian university which used to run, it was amongst the pioneers where Google and others have invested. Now I am using TensorFlow today and tomorrow for you to explain, where this API has, it's a large library at one level, but the important aspect is how they store the data. Tensor is nothing but array. So in the array for fashion and in a hierarchical arrays fashion, the data is stored in TensorFlow. So this library helps us in the neural network models. They have pre-defined functions and classes, functions and methods, so you can just call them and do it. Now, another thing that has come up is on the top of this, there is a wrapper that's been created, which is called Keras, which further oversimplified in just 3-4 lines, you can run this entire code. So for Keras to run, since it is only an interface to TensorFlow, PyTorch, and Theano, I think it works on all the three Keras. So since it's only an interface, so you will have automatically in the background whatever you have called, the TensorFlow will run. So if you have connected it to TensorFlow, automatically in the background TensorFlow will run, then only Keras can be executed. So at the end, these are simplified functions that we have. So we will have to call them and run them here. So I already have pip install is the term you use here. Let's say I will type here for you. How do you really get this? We will also give you, if you have not already got pip install, you can do and install TensorFlow and Keras you can install. Now, once you do it, let us do for a simple network. If you have to do, let's say we are talking about a multi-layer perceptron. So multi-layer perceptron or ML, single layer perceptron or multi-layer perceptron. You will have some input values here. I'll keep it. Then you have a hidden layer here. And I also said let's say you have one more hidden layer here and you run it. And finally you have an output layer. So here these are all connected like this, and it is a densely connected, and I spoke about dense connection you can do. So and then you can also, I said, drop out so that your overfitting can be avoided. So the way you can, so the what we do is dense is a function, and we can add layers one after the other. Drop is dropout is another function. So if you are doing a convolution, then you have convolution 1D, 2D, 3D. We will do convolution 2D is another function that we have. And given the time, I think we will run two examples, one of an MNIST simple one. Then you can, so some steps that you need to be familiar in a machine learning or the network models are also, one, you have to get your data, probably I will write it in a separate page, is so first thing that you got to have, probably I will not use this, and easy to type once I will take. So the steps in the machine learning that you have, first one is understand the data. So once you understand the data of what you have and what are the data types, etc., and second one will do is, so clean the data or pre-process the data. Pre-process the data. So you got to convert the data into understandable terms. So if it is so numericals, it's fine, integers and continuous values. But if it is ordinal or categorical values, how do you convert it, etc. And prepare the data, and then scale the data also. Scale the data so that it's all comparable. Now, once you pre-process it, then you go and the data set, you split that into train and test, or you can even split into train, validate, and test. Yesterday I said within the training, test is completely for a different purpose. Within the training, train and validate you can make so that you can do internal validation once again. The test validation is different. Once you do this, then you have to call the model. So whichever model you are using for pattern identification, you call the model. So typically there are, so the output of this, it has to give you the W values and B values. Now there will be certain parameters or hyperparameters we call. Hyperparameters is to tune the functioning of the model, to tune the functioning of the model. So once you have this, so you will fit the model so that it is ready to do, and then you will compile the model. So when you compile the model, this is where we will get into there. Now, when you are also doing a pattern model definition, you will use a certain, yeah, compile and then evaluate the model. So this is where in the compilation you will also use what are the uh, loss function or error determination method you want to use. Yeah, you can also, here we will use the error determination method and so on. So we will get into the details of error determination, error rectification, etc., where we use these high level steps from a programming perspective. I'm sharing. Now we will go into the details of it. One of the programs. Very quickly this one, but when we move to CNN, that's where I will spend a longer time to explain the details. Now let's share a good example of, just give me a moment, I will search the data and then come. All right, so let's look at the data where we have, it is there in this FDP. Yeah, it's good. So I have this MNIST, you may be familiar where MNIST is the data. We'll take break in 5 minutes. So, so if the MNIST that we are these numbers which are handwritten, or you can say handwritten digit data set, is these are all NIST or MNIST that we talk about, Modified National Institute of Standards and Technology database. This is the full form, Modified National Institute of Standards and Technology. So these are the numbers, and we will have to predict what this number is. The machine has to then look at, understand the data in this format, and I'm hoping you are able to see when I cursor down. So let's So this is how the data in the MNIST database that we have here, the data is presented, or the next one. Then machine will look at the position of it, take the data and understand, interpret, and so on. Now we will look at one such example here in this in MNIST, how I can run. Though I've used the convolution method here, do not worry about it for now, because we will look at the other powerful example of convolution where we will try and see just after the big German traffic signal. But to share high level that one, which we will go into the details tomorrow, today I have to tell you completely about the convolution methods. Now, in this case, I need a computer vision to be viewed, so I import that file. So this is the file that I started MNIST for you. Then matplot library is for visualization. So in this pipe plot is there for X and Y axis. So, and Seaborn, another visualization tool I have taken. Now, apart from that, importing Numpy and keeping an alias, and Keras is where from Keras models I'm importing sequential. So the entire our data is all sequential in nature, sequential, model, and input. These are the three things we will use. Then from Keras layers, import dense. Dense is where fully connected. Dropout is if you don't want all are connected, so dropping out some percentage of them to avoid overfitting. Activation is sigmoid or softmax or relu that we want to use. Relu is a common one for the hidden layers people use, and because it has some good advantage. Flatten is when you want to flatten it and move from a convolution model to a flat and let's say from convolution 2 that we are talking about artificial neural network, which is multi-layer perceptron. MLPs or single layer, multi-layer perceptrons. So it's called fully connected layers. So again, you can do a convolution 2D or con 2D max pool. We'll see which one we have. Then from Keras utilities, we can we will import utilities from Keras and then data sets. So this particular one from Keras dot data sets, Keras by default has some of the database within it, data sets within it. So we are calling their MNIST, so we don't have to explicitly read from outside, and I'm just calling it from there and studying here. Now, so this is how I'm downloading the file. It already has X train, Y train. So this test split is there, training data set and test data set. So train and test. Y is nothing but our target variable here. Y train, Y test is a target variable. So mnist dot load underscore data. So NumPy has this facility. You can load the data. Now, then I'm saying, I'm look at the shape of the X train, the training data set. The shape of it, I want to reshape it to the first index being 28 by 28. So what we are talking here in the 28 by 28 here is the in a pixel. So the picture that you have, I'm saying I'll have 28 rows of pixels and 28 columns of pixels and 28 rows and columns. Now, normal your photograph, your camera will have 5 megapixel, which means I think it is much more than 1000 by 1000 pixel. So, or nowadays it is all high tech, more than 1K by 1K. So what we can do is we can trim this down to 28 or 32 or 64 by 64 if the accuracy is not clear. So it is manageable. We will look at that again. So that is where, and then it is one channel, so which means it's a gray colored data, and X test is again, it will be similar to the train, because training is the split we made and test is another one. And of course, I'm also saying the data type is float, because when we scale the data, it becomes easier. So obviously here, I already told you 0 to 255. I will explain all of this, but I want you to be familiar, the still shaping part. After the CNN explanation, I will take you through the same data set and explain, and we will do a code, we will go around the code. So I'm hoping by after today you will execute this, and tomorrow we will look at German traffic signals one, and also I will talk about a post detection project being executed. We'll take you through that is tomorrow. We'll take a quick 5 minutes break. At 11:16 when we come back, I will look at the questions and I'll try and answer for the things that I'm familiar with. Wait for 2 minutes and then start.
So it is starting from.
Good morning all. This is Anuradha from BlackBuck Engineers, and in coordination with Anurag, today we are on the second day of the faculty development program, which is Convolutional Neural Networks. Hope you are enjoying the session and the training is up to your expectations. If you have any suggestions or if you have any training requirements, please text us back, and then we will look into conducting those faculty development programs going forward. And before I start explaining about Centers of Excellence, I would like to thank Anurag University to give us I would like to thank Anurag University for giving us this opportunity to conduct the faculty development program to all of you. And special thanks to Mrs. Santosh, who is Industry Interaction Coordinator for Department of Electronics and Communication Engineering of Anurag University. And thanks to the HOD, Dr. Satish, who has given us this opportunity. And also thanks to the Director, Chairman, and the Secretary to give us this opportunity. So going into the BlackBuck Centers of Excellence, what we perform as part of this Centers of Excellence is so Centers of Excellence is we are concentrating mostly on emerging tech. It's at the moment it is artificial intelligence, machine learning, and data science. That's where all the action is in the industry at the moment. So we are concentrating on this, but we are not limited to this. We will be conducting more sessions related to blockchain or Internet of Things or cloud or all the new emerging technologies. So as you see on the screen, we are established in 2013. We are into training programs. We especially train the corporate, and one of our flagship program is Executive MBA program, where even vice presidents and people with 25 years of experience from corporate join us for this program. And Centers of Excellence is our latest flagship program and a highly successful one, where the students and the faculty are taking advantage of the industry expertise in these areas. The expertise is all in industry, as you know, so the students are being able to take advantage of the industry expertise that we bring onto the Centers of Excellence. So as you see, what we are trying to build is not just a training program, this is an ecosystem. We have partners with the government, we have partnered with NASCOM, with government, with a lot of research organizations which are deep into artificial intelligence, and then we partnered with academia and industry and we bridge the gap between both actually. So the industry brings a lot of hands-on knowledge or the practical knowledge to academia, and academia is able to bring the structure to this knowledge. So we bridge the gap between industry and academia through this. And as you see, the connected workshops is one of the most important things that we are bringing. There are usually number of workshops that happen in the college, but what happens is the student will not be able to gain much if they are not connected. So if connected workshop, an example is the student can learn first statistics, then machine learning, then deep learning, and then artificial intelligence. So over 4 or 5 workshops the student gets complete understanding and they are connected to each other. So that's how this makes really very interesting. And it's not just into deep technology, right? The workshops are also into say process based, say Six Sigma, processes. So it is process based, and for people who are not interested in deep technology, they can go to testing based. So they are all connected workshops and different streams that help the student to become industry ready for one of those roles. So these are role based connected workshops. And then we also, as part of the Center of Excellence, provide incubation and innovation services. In the sense, we conduct hackathons and ideathons and select top 2 ideas which we can build as prototypes and connect them to the industry from where they can take it forward. So it is very difficult for the college to take up the responsibility of a complete startup, like find the marketing, do the marketing, and etc. So we connect them to the industry. From the prototype onwards, the industry takes it forward. So career guidance and industry mentorship. So what we have is, every week we have webinars from the industry people who talk to the students on what is happening currently in the industry. And every week on Saturday we have a mock interview program where 4 students volunteer to take an interview from a real HR, and other students learn from what are the questions they ask. They see a real interview and learn from it. And what is happening is, these HRs are also offering the students directly some internships immediately then and there. So very beneficial to the students to learn. Instead of on the blackboard, they see and learn on how actually interviews happen. And as I said, through entrepreneurship support is through hackathons and ideathons. We choose ideas that can be taken to the market. And webinars and guest lectures. So there will be number of things like how to register a company, how to get loan from a bank, how to register an IP. So all these entrepreneurship support we do as part of the Center of Excellence. And as I said, there will be lots of webinars and guest lectures and hackathons and ideas. So for the faculty especially, I would like to also say that we want to support the faculty with the latest courses that we are introducing into the syllabus. Artificial intelligence or data science, that is getting quickly into the syllabus of the students. We want to help them through our own presentations and help them through the practicals in the labs. So we will be providing a lot of support to the faculty in conducting these latest technologies as classroom sessions in your own college. Okay, so these are the faculty benefits that we have. We bring industry interaction for the faculty and faculty development program, which you are right on it today. And we also bring consulting projects from industry. As I said in the last time, if you were there, we brought in a Nagarjuna Fertilizers industry project to one of our partner colleges, and the project that the students have executed, and this NFCL is really using that. Currently they are using that program. Okay, so we also bring consulting projects to you. So these are the benefits that you have. Number of training programs to the students, and most importantly, what is best among all these things is a social network for the student. The student will be put into a social network very similar to the LinkedIn, and the student has a learning portal. He or she can have a look at the webinars. He or she can look at the training programs whenever they want, and they can compare using testing process. They can compare across other students where they stand, and the HRs also post their hiring requirements onto this portal. So this portal is best for the students to have, and we introduce this portal wherever we are in the colleges that we have, as we have our centers of excellence. So, and the career supports to the students, we develop their profile and portfolio in LinkedIn and social network. We counsel them for higher education. We bring them, we help them in how to set up a own company, and help them in their entrepreneurship. We help them in jobs and internships. So the Center of Excellence is one-stop shop for many of your additional requirements as a college than your the strong teaching that you bring to the students. You need a lot of industry support, career support, and bring the students towards the industry. So this all additional support that you need to your college is provided by us. So incubation industry is what. So, and as I told, this is supported by Government of Telangana IT department, and they are helping us promote in various colleges. So wherever we are, they give a strong support to us for certain activities for bringing the industry or for bringing them some initiatives primarily onto this center of excellence. So we have university tie-ups, we have industry tie-ups, we have HR tie-ups, who there are around 800 organizations in the tie-ups that we have, and they bring HRs and also jobs onto your campus. So we are the team. This is the team that you see on the and Mauli sir, who is teaching you, is our chief architect. So he will be helping the in case the faculty has some questions, has some research idea, he can help them formulate a problem, he can help them formulate a solution. So these are our facilities that we offer through our center of excellence, and we have a roadmap. We want to tie up with around 50 colleges or universities, and in this academic year we are already through till 15 tie-ups that we have already closed. So if you are interested in having your center of excellence, you can post in the group, or I have yesterday given a phone number of our one of our lead marketing person, who is Raj. You can ask him about the details and he can share you more details about the program. Thank you for giving me time. You are here for learning and I have taken some 10 minutes of your time. But if you are interested, please let us know. Once again, thanks to Anurag University for providing this opportunity. Thank you so much.
All right, welcome back. I think the more important aspect is kept for the last 1 hour. I would put it like this. Let's also look at what we can do is there are a number of questions that have come, and we will probably look at these questions before we get into convolutions. I'll take a blank slide for us. All right. So the first question that I have here. The dense network is fully connected layer, but why dropouts are used in dense layer? So we said dense layer is there, which is fully connected. Now in that case, why do we use dropouts? The reason for using dropouts is when we think that it is overfitting the model inputs and let's say hidden layer, and it is overfitting, then you will say, okay, drop some of them so that overfit will not happen. If it is overfitting, then it will accuracy for the training data set will be extremely high. The variance, the minute variance in the trained set will be captured, but when it comes to the test set, it will not fare well. That's how you use some dropouts while you want it to be fully connected. So however, it randomly also drops some connections to see which are probably not value adding. Subsequently it figures out whichever is not much of value add. Next question is how to identify the learning process is complete or not to avoid overfitting problem. So after every epoch, we call it as after every iteration, you get to see the accuracy score. In Keras we have this accuracy. Now if the accuracy is going beyond 99, 98%, that is the time you say those many number of epochs are sufficient, and from there you just take the parameters W values and B values and export it somewhere, and that becomes your trained model. So you would know that which epoch you got to start it. In you have many dense layers, I think number of epochs also can be lesser in those cases. Is the only alternate to changing the learning rate to avoid vanishing gradient. So we have vanishing gradient problem. We spoke about gradient descent like this. However, sometimes you can have the gradients like this. So the bottom of the valley is somewhere, but we have not seen where that is. Just a moment. We have not seen where the bottom is. The machine can get wrong. It could consider this as the bottom, it could consider this as the bottom, this as the bottom. So it has to go. So making sure that it gets it right. Explosive exploding gradient and vanishing gradient are the problems. I will come back if there is what are the other ways other than the learning rate, that regularization function, the learning rate that we spoke about, if there is any. Next is, because of sigmoid activation function we can get vanishing gradient problem. If it happens, then the updation of weights won't happen. Then how can we converge? Yeah, it's again same thing with the sigmoid, you can have a vanishing gradient. So we will look at that. Next one is, the question is not related to neural network. In SVM, why we consider the dual form of SVM and what is the use of kernel tricks? Yeah, probably we will take, I think, kernels. There are different kernels you have in the support vector machine. You can have those vectors here, and the kernels will help you in creating multiple clusters. So there is this gamma value that you have, and kernels we will talk about this tomorrow when we have more time in SVM. Next question is, please discuss one-dimensional CNN with the time series example. So we will today deal with two-dimensional. Again tomorrow we will see one-dimensional. If we can work con 1D you have. If it is a time series problem, I recommend you go for RNN. That is a better method. You have more accurate time steps are well captured in recurring neural network model. So however we will see tomorrow based on the time bit. Okay, now the important aspect, we will get into the CNN part. So convolutional neural network, I have a set of slides that I have put together, we have been working on these slides only. Now some bit of inspiration while I will provide initially. So when you have an image like this, again there is a load shedding and I'm not sure you will be able to get this going. Let us also wait and see if you are able to. Are you able to hear me? Can anybody help respond there if you are able to hear me? In between, did you have a pause? I can see the questions here. Okay, so probably I'm not able to see whether you have any buffer or not. Hopefully somebody will help me in case you are not able to hear. Alright, so we will close this neural network. We are now at the CNN. How does the computer read an image? So this is an image. You have different colors. The colors are coming from these three channels, red, green, blue. So this is how the computer sees, and each channel it will see everything into a pixel format. So those pixels, let's say I will take a white color here, and so everything is a pixel here. So each pixel it reads and then takes the data. So if you are taking a small piece of the data, you will break that, and that becomes your big value and so on. So while we are at it, let's move to the next step and understand more details. Now these RGB are again the pixels. They are appearing in the form of these channels here that you notice as three different channels. Now the way it is presented is, you have the rows, column size of an image and the number of channels. This is how computer reads an image. Now you can push this data into a network model. If it is a fully connected layer or the multi-layer perceptron model that we are talking about, you have something like this, and then you can present it into it. So these are the input values that we are going in. So the moment you have 28 by 28 by 3, it will be everything. You will have 28 into 28, you keep it, then 784 into 3. So you have 2352 cells, one after the other. They are all presented if you are going to take. Just a quick illustration. So the machine reads an image in the pixels only. Everything is like yesterday we discussed, everything is one pixel. The pixel value ranges between 0 to 255. If it is a 0, then it is so black color. If it is white, then it is 255, where all R, G and B are full colors there. So that's how the representation is. And then each one becomes one input variable, or the independent value x1, xn. So you will have 2000 odd x1 to xn we have just computed calculator wise. So we have just computed 28 into 28 into 3, 2352. So those number of variables that you will have here and the value that you could predict on the other side. Let us now how a CNN would look like. We will probably this is the entire method of convolution has emerged from the animals. It was a study on cat by a psychologist that was done, and that's how it is built in. So while these are at a high level that you can have, but I think before going in there I will try and present the data in some sort of a form. You have these let's say this is the image that we are dealing with, and in this image you have all these pixels which are, let's say, 28 by 28 that we are just talking about. You have 28 by 28 pixels. Now the weights and bias that earlier we had, it used to be a more sequential, all are connected directly. In the case of 2D convolution, this is two-dimensional convolution where it remembers the data of rows and the columns data. It will remember one which this value comes in the second row, first column. That kind of representation is there. In this case the weights are presented in the form of a matrix. So you here also you will have, let's say you have 3 by 3, so you will take 3 rows and 3 columns. So now this the weight cluster, let's say this is weight cluster, and this cluster is called filter. So the idea in the convolution that you do is you will slide this filter through this image. So I will probably present it slightly differently. You will slide this filter through the image, which is earlier you were doing a w into the x value, wi xi value. Here you are going to do a dot product. We will talk about the dot product soon, and then you will slide the filter one after the other so that it is not a straight multiplication of just one value, and that's how you will get what is known as a feature extraction map. So we will do using an example exactly how it happens. Now a feature extraction map comes that once you have the data which is an output from here, you will then, that is nothing but your sigma value you will get. In the sigma you don't do a straight wi xi, you will do this dot product multiplication, because here it is a matrix. Here wherever it appears, that is becomes matrix, and then it goes to the next 3 slides, next 3 columns, next 3 columns. Once the row, all 3 rows gets over, it goes to the next one, and so on. So that's how it creates a feature extraction map. So the new one. So now the data that you got is sigma, you will have to then quash the data into some, bring non-linearity. Let's say we use sigmoid function, you have, or ReLU. ReLU is most popular. It is a linear unit. However, some bit of rectification happened to the linear unit, where you are saying whatever value that you have here, which is mx, that this is mx provided it is all positive. If it is negative, it becomes 0. That is what is the rectification that happens. Otherwise here also y is exactly same as mx is the view here. So once you have this feature extraction map available, once you get that, the next step is that the values which are here, you will pool them into one method is max pool, because essentially what we are looking for is some sort of a brightness, which is the number 255, more tending towards 255 when it is 0 to 255. So whichever is the highest value in a cluster, let's say you take another cluster method of 3 by 3, so you will see which one you have and take that value and pose in the max pool. Let's say if it is a single convolution, it happened, there you have step 1, then step 2. 2 steps that are there. However, now in the sigma and activation, you use a filter, and this filter is applied, and then you only take the maximum values here. You have multiple hyperparameters here, we will talk about that. So once you have this max pool data, you will then push it to the fully connected layer. Again, these are the input cells, and then you have a hidden layer, then you have an output layer, then it is full densely connected, and so on and so forth, and that gets over. So this is how we can do it. Now this becomes the next step. However, there are many many hyperparameters that you can do in applying this filter to get a particular feature extraction map. And you can also do the pooling slightly differently. We will look at it through more examples. In this case, you have this is an image of a bird, and that goes as an input layer. Let's say this is we are dealing with the case of flat or neural network ANN, which is the multi-layer perceptron. You have everything, all pixels becomes flat like this as an input layer, and you create some hidden layer 1, hidden layer 2 and hidden layer 3, and these are all densely connected or fully connected. Then you have the output, whether it is a bird or cat or dog. These are 3 classes, so you will use a multi-class classification. So therefore here you will use in the processing a softmax, and this side you will do the addition or the combination of the values or addition sigma of the data. Similarly here you will use a ReLU function. This is what normally we are doing in the under artificial neural network ANN. Now if I have to take this further, these hidden layers, the more explanation is available. Now let's say that this is a CNN model and this column is a convolution layer. So, and this is a ReLU, and this is a pooling layer. So I am moving from the fully flat hidden layer to a convolution layer. Now in this convolution, so strictly speaking, in the convolution the value will not be independent, because we are always looking at this and this as a single neuron normally. Here let's say we have because both addition sigma as well as the quashing both are together in the neuron, so these two are together. We will look at this convolution in greater detail. Pooling I already spoke about, whichever is the maximum value in a given set of metrics that you take, whether you take 3 by 3 or 5 by 5. So you will then go and search in your overall picture every 3 by 3 there, and depending on the step that you take, and you only pull the biggest value and present for yourself. This is how we can do. Now coming to the next level of details, your output layer we already discussed. Of course, so the man behind this, who was earlier with another company where the postal address purpose, zip code purpose, they have used the convolution method, which subsequently became very popular. I think LeNet was what they created. In 2012, Alex and the other researchers have submitted their model to solve a problem in the ImageNet. So that popularized this entire convolution model subsequently, and there are many great people who contributed to this method. So what exactly happens in this convolution model? Let us look at the details of it. We'll start with a simple MNIST kind of data where a digit has to be studied, and if you are looking at this digit in the machine here, so what we see, the image is like this. Now how a machine converts this is, it will make into everything into a pixels. So these are all pixels that we are dealing with. I will delete it, and probably I will use a pencil here. This could also, I can use this, and the pencil color could be red. Yeah, all right, red I can use. Now these are the pixels that we are dealing with. Each one is a pixel. Now you will notice that in this pixel there is a brightness, more value is here. Let's say because this is light, we are seeing the background color as white and black as the number. In reality, if you are in dark, you can't see black color at all. That becomes 0 and the remaining 255. However, for us, we will use just opposite colors for representation. So you will see that this cell, these cells have some value and the other ones have no value. So here you will notice the actual pixels. If you scale them down, everything to 0, from 0 to 255 to let's say 0 to 1, you have scaled it down, and then the results are either 0 or 1 you have kept, and you will notice that wherever there is no value, it is all 0, and finally the 1 is what you have the value, and you see this is the 8 that got formed through this. Now this is where you will notice, and rest all are zeros only these cells you will see that being 1. Now so in the convolution dot dot product, what we are saying is, so you will combine two. So here it is more like using two matrices. Probably the explanation is, when you have a value, a is 597 and b is 123, you will use this as 123 as a filter and work on this data. First you will look at the 532 and multiply. Next you could look at the 325. Next you could look at 259. Next you look at 597. So 1 2 3 4. So you will generate 4 feature extraction maps in this. So multiply the array element wise multiplication, you will get 5 into 5, 3 into 2, 2 into 3. So and then you add all of this, sum the product. This is the dot product value, which is 17. Similarly, the next one is 3 to 5. So 3 4 15, and you will get this value 3 4 15, which is 22, and the next is 259, and next will be 597. So you have this data, and if you sum the product, you get the new values like this. Now the same new values you can present depending on how you are taking the data. Now let's say we will how CNN recognizes images. Another illustration is, if you have an image like this, essentially you have some sort of brightness color here. So these colors, again you will see exactly same thing, and one will be here. I'll simply mark them so that you are also able to see this here. And then you also have this line. Everything is zeros here. Image represented in the form of matrix of numbers that we are talking about. Now the steps that we have, one is a convolution layer. I would put this convolution and ReLU as a single one, these two as single one. So because here convolution, you do a dot product, and then what you do is you quash that so that you get an output. And if it is a neuron, you got to have both of them within the same layer. Now in the convolution layer, it's a more detailed example of what we discussed. In the first step of dot product, what is happening? For the example, let's say this is the image that we are dealing with, and this image has 5 by 5, there are 5 rows and 5 columns here, and 5 by 5 pixels that you have, and you have scaled down everything to 0 and 1. That's all, and gray scaled down to zeros and ones, and this is what you have, and probably picture is something like this. And now you using a filter. Filter is nothing but a set of weights. You have your weight matrix, I'll call it as weight matrix. You take this weight matrix and then convolve it. So you keep this on the top of it, something like this. You can overlay this number, and then you see what is the value comes. 1 into 1 is 1, 1 into 0 is 0, and 1 into 1 is this, 1 into 1 becomes 1. So then similarly next is 0 into 0, 1 into 1 and 1. So another one is here, then 0, 0, 1 into 1, another one is here. So you have 4 ones here, which is 4. So you see the first value is 4 here. Similarly, then you move this same weight matrix to the next level of, let's say I will change the color. So second one to maybe blue. In the second one, you have this moving to the second one like this. Now in this case, you will have again do a dot product of the values. 1 into 1 is 1, then 0, 0, then 0, then 1 into 1 is 1, 2, then 0, 0, then 1 into 1 is 3. So you have 3, you will get the next one. So then you will move here next. Then once you complete these 3 here and you come down here, so then you will have, let's say I will change the another color to something gray, and once you complete the remaining here, which is this one, and then you will go down and do the next 1 to 3 and so on. So complete another cycle, then complete another cycle, you will finally get a 3 by 3. There is also a formula that we use. Typically you have, let's say your image pixel, original image I minus the filter size. Filter is nothing but a matrix of weights, minus the filter plus 1. So for now we will keep this. This is the image size, this is the formula. However, we also have the strides image size divided by the number of strides. Stride is the transition of the weight matrix on the top of an image. So if you look at the stride that we had, we used only 1 unit of movement. Suppose if you use 2 units of movement, then the stride is 2, S is 2, this is more like a hyperparameter to avoid overfitting. If you have sparsity of the data, you can increase the stride sizes and so on. Now then, after you do the first one, then second one will skip 2 and then this becomes second one. Now you will have only the final output that you will get here also you skip. In fact, it will not be you will skip 2. All you get is only 2 by 2 you will get, because here top 2 and next 2. Instead of 3 by 3 in your convolved feature or feature extraction map, you will have only 2 by 2 if you use stride as 2. That's a formula: image size minus filter size plus 1 divided by stride. In fact, we also said size plus 1 is here. This is how we will keep the formula. You will see that in the next step. We have completed now dot product or the sigma that we normally do. Next we have to do is a ReLU or some sort of an activation. We will do it. More details of what we just observed. You are doing the dot product 1 into 1. So you have done this. So let's say I will change the color of it. So I'm not able to change the color, but let me see this card. Yeah. Let's say now the color is red, or we'll go with blue. Now you will notice that this is 1 into 1. Here you have that multiplication 1 into 0 here and 1 into 1. So basically this one is multiplied with this and entire series, then all of them are added. You also have another method where you divide it by the number of features that you are dealing with. So this 3 by 3 matrix, so you would say divide by 9. So we can avoid that model for now. Now this is the filter, which is nothing but a weight matrix. So you can have 3 by 3, you can have 5 by 5. So you can use this method. These filters are also called kernels. These are kernels, or these are weight matrix, or these are the weight clusters. Now, so you will have a convolved feature. Earlier a simple sigma is now going through this step. Now once you have first one phase done, you will move with one stride movement. You have moved one stride and then you are computing here. Then so the convolved feature, this is a graphical representation. You please pay attention to it. So how the multiplication is happening here, how the dot product is giving you a result. So all of them you get to see. So first one 4, then second one 3. So that like this, it is all transitioning into the new details. Now we have completed one step, which is convolved layer. Now we will keep do some sort of a quashing or activation of that. We are using a ReLU. As I said, ReLU will take all negatives to 0. You will notice here all negatives became 0, and here it is y is nothing but a linear relationship. Y is nothing but some sort of m into x, some value into x. So that is y. So there is a linear relationship that is being established. So there is a significant advantage. So this is most preferred in the hidden layers. Now let's look at an input like this. The advantage is with this kind of activation, you will still get the features of it. So you will be able to identify this particular feature of the bird and branch. These things we will get to see. So each feature maps are this, and then you will use those filters. The weight matrices, there will be many weight matrices. You will use them to prepare them subsequently to test. Now once you complete that process, then we spoke about pooling. Max pooling is one method, and we will of course average pooling is also available here. So whatever is the combination that you use, let's say I am using here 2 by 2 is what we have used, sort of a matrix. You combine 2 by 2, whichever is the highest value here, you take this value and say that this is which is the highest here. 20 is the highest in the block, so I go and present here. Similarly, next one is 30, in this case 112, in this case 37. So you will see that all of them are pooled. There is also something called average pooling. So you will average all these values, which is 52 by 4. so the value is 52, sum is 52, 52 by 4. This is another method. In any case, you need a bigger value to say whether there is a feature or not. So those features have to come, and even during occlusion, convolutional models are used, because even in occlusion, even in different light shades, etc., it still be able to predict accurately, because somewhere, anywhere in the image, if it looks at the combinations that are matching, so that's how it predicts. So another example, or another way of presenting a pooled feature maps, if you have a 4 by 4 matrix, after the activation function, a convolution and activation function, they will all get combined and pooled, and data is generated. For example, 3 4 1 2, and in this max of 3 4 1 2 is 4, so therefore here you see a data of 4. 2 by 2 filter is used with stride 2. So because if you see, the unit of movement is not 1, so it is 2, so it is moving to 2 steps, so then the stride is 2 used, obviously, then we say, and the filters that are applied to generate this max pool is 2 by 2 filter. So this is a common step, common method. So in the filters for convolution, you use 3 by 3 weight matrix, and here you use 2 by 2. In this 2 by 2 filter, you only take a max pool. There is no another superimposing layer. It is a blank layer that is being pushed at one level. So you have this data, and you get these edges, corners, and other features of the bird. You will get more details of it. This is what gets stored. Eyes, beak, all the details you will get. Now, if I have to present it for multiple filters, if I am using, let's say this is the input image, and I have, let's say, 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, it shows 12 for now. So let's say I have used 12 filters, so then every filter will generate for me one convolution layer. So because every filter that I create, so the size of this will be lesser. Let's say these are, each filter is of 3 by 3, and the stride is 1, then what I will get is 3. So the filter size, the image, original image is 5, minus filter is 3, since stride is 1, so divided by 1 plus 1, I will have 5 minus 3, 2 is equal to 3. So the values here are nothing but in the convol layer, I will have 3 by 3 is what I am left with. However, since we use 12 filters, we will have 12 different convolution layers, 1 to 12 layers you get. Now all of these data points are quashed, nothing else except for you use a ReLU here. So once you quash, then you will pool, you identify again within this what is the maximum. Let's say you have used stride of 1, and a 2 by 2 filter you have used, then what you get as an output from here is, if you say this 2 by 2 becomes one value, and then this 2 by 2 becomes another value, so basically you will have just 4 values here. So similarly bottom also 1 2 3 4 values. Now the 4 values on each of the pooled layers, and totally how many are here? 12 convolution layers. So you will have here also 12 pooled layers. This 4 into 12, all this 4 into 12 you will get converted. Let's say if you are going to fully connected layer, this every 4 first becomes flat, 1 2 3 4, let's say the value, and then 5 6 7 8, so it goes on and becomes flattened till the last value that we are talking about. 48 is the value that we are talking about at the end. So that's how it gets flattened. So this is one single convolution. There are more hyperparameters. If you have some data in the edges, so to avoid losing the edges data, here edge, here edge, you can do a padding on the top of it. So you can have single padding, you can have double padding, you can do. So we will also talk about this in a moment. The padding. So in the padding, what you will do is you will keep 0 0. So you are not adding any value to the image. So image remains intact. It's just that you have these padding will help your edges not lost in the process of this strides and convolution. So now let's look at flatten bit, what happens. So when you flatten this, we discussed that the 6 8 4 7, first is the row, and then the column gets, and then next filter or next pool will get covered. So after this next one, after this next one, that's how the order gets followed. So they get added here again and again, and then they get added here. This is called flattening. Now this is how you flatten all of them into 48 here. Let's say these are 48 because we looked at this is 4 and these are 12 that we have looked at. This now when you bring it down, put everything structure of the network. So far you have seen the original image, you have used filters, and then you convolved the data, the convolved was squashed, and then you pooled. So the numbers, it say this is a 5 by 5. The original 5 by 5 became a 48. How it became 48 in filters? You used 3 by 3 with the stride one without any padding you used, and let's say these are 12 such filters. So each one has generated 4 by 4, but then 12 values, it has 12 such layers. This 4 by 4 became 2 by 2. The 12 layers, 12 remain as is here, and then now it is 48. So 5 by 5 had 25 data points, and now you have 48 data points that got generated from the same input. Alright, now fully connected network is that 48 which is here goes through a hidden layer. Typically the practice is, if you have a 48 here, use 50% of it for the hidden layer, 24, then another 12, maybe then if you have 3 hidden layers, 6, and finally this is 3. This is sheer incidental, but you can even have just 2 layers, first one 24, second one 12. So we will say when you are reducing the size, preferred is 50% of it you use next. However, you can always, there is no hard and fast rule. You can make it to 5, you can make it to 50, there is no problem. It can be more than this or it can be less than this. So the flexibility is there in the hidden layer. How much of the data learning that you want? The apt size that I observed more frequently is 50% of the input values gets here. Again, for this input is this, so another 50% of it, and 3-4 layers is what I see as the hidden layers. Now fully connected, if you do the entire exercise, you're done. You found whether it is dog or bird or cat, and you accurately predict as bird. Now so this is a fully connected layer. You will notice here it is now combined with the complete network. This entire process is convolution, so convolution network model or convnet model. So we are calling it as neural network because it is similar to the biological neurons. So this is a convnet model. This is an ANN, artificial network model, simple or fully flattened layer. So this is FFL is another denotation for it. So the way exactly it is happening is how CNN recognizes a bird is it takes every bit of it, and then so the data is appearing here in the form of this should be filters. So these are all filters. So you will have all the filters of small sizes, and these filters then get represented in the convolution. Then you have this as squashed data and so on. It's a repetition. Now spatial dimensions is important. When you have typically you have 3 channels, not grayscale all the time. You have red, green, blue. So how you work with RGB, this is adopted from online, and courtesy credits I will share again in case it is not available in this document. Convolve all over the spatial location. So it will go through these filters, go through all the 3 channels, and you will get an activation map which is of a single layer. It gets flattened as a single layers because it goes through all 3 locations or all 3 channels and give the data. Alright, you can see these details further, but I think it is important for us to look at how this runs in a model. But before this, padding is an important topic that I did talk about. To avoid losing your data in the corners, mainly you can use padding. Padding also helps in bringing down all the image sizes to similar. So but the padded values are 0, so it will not impact at all. When you finally do max pooling, they are 0, so they don't disturb your actual values. The advantage once again to say that corners data is captured. So 7 by 7 data, if you have spatially assume 3 by 3 filter applied with stride 2, then stride 2 is 2 units are jumped. So first one is here, second one is here, and then of course third one you will have another jump from there, which is like again you will have to skip this 2, then you have this as third one. So if you use stride 2, this is what you will get as a data point. Now if I apply that with the stride 2, you can look at how much information we are gathering here. Now I also spoke about the formula to compute what will be the output size that you get in a conv layer. So this is the input image. It is original image or whichever is the image length, and these are the filters, that size of the filters that we use, and this is the padding. In case you have padding, then you keep +2 padding, because one pad means you have zeros all 4 sides, and so you have zeros this side and this side, so therefore we say +2p divided by number of strides and +1. This will give you what is the output length that you are going to get. It's so to remember. So if you have a stride 3, then it will not fit, because after this you have to jump and you keep here, and then you suddenly realize that this data is getting lost. This is lost. So this is missing opportunity, or I would say the stride size has to be smaller. This is another way to present. So in any case, it is the same, whichever is the term that we are using. Now you can have multiple conv layers. It is not only one convolution that you will have all the time. You can have, this is one conv, this is second conv net, this is conv layer, this third conv layer. You can use max pool either after every conv layer or after 2 conv layers also you can use max pool. You can flexibly use it depending on which is giving you more accuracy. Alright, now I will output volume size if you have 32, so we can look at these details as we go ahead. Maybe quickly see if 32 by 32 is the image and 3 is the number of channels you have, and you are using 10 filters. So you have 10 filters of 5 by 5 size with stride 1 and 2 pads, which means this side 2, this side 2. Then what is the volume size that you will have? So if you have to compute that, you will take 32 into as the input image size, then filter size is -5 plus the 2 times of the padded value, and the 2 padded value 2 by 2. Now the stride is 1, so you have kept divided by 1 plus 1. So 32, since it is spatially it is, but the number of filters are, you have 10 different filters. You have this value 32 appears 10 different times. You will have 32 by 32 by 10 is what you will achieve. Alright, now example, more details are available here. I don't want to spend time. Now is what are the steps which are there to implement. Since we are going to look at MNIST, let's see quickly this data. Now you have something like this, a number 2, it will use some filters to get some convolution 5 by 5. Filter also is called kernel. There is some padding or no padding here, and you have convolved data you will get. So that gets max convolved, which means you will also use activation here, and then you do a max pooling, and again you will do convolution, again you do max pooling. So 2 times it is done, and finally you flatten everything so into fully connected one. So and then if the numbers digits are 0 to 9 always, so it is 10 different classes. It's a 10 multi-class classification model that we taught. So this is called CNN architecture. Now let us look at the simple example that we were seeing. There are more, so you have the steps here, which is fine. Let's look at what we have, the example right now. Before the break we said we were going through the MNIST data. We will now see the same thing, and let's say Control C. I will run this file once again. It is already in my virtual machine AI training, so I will just call Jupyter Notebook. So I have already installed TensorFlow and Keras, so they work default, and I'll go to DPCNN MNIST. So in this file, the initial steps, I'm assuming you understand, we imported 2 libraries which are visualization libraries, CV2, to deal with the computer vision, to read an image. There are another one is SciPy you can use, that is in fact faster than this SciPy you could use. These are the models from Keras. I am taking sequential, etc. I will quickly run this so that they will all work. So asterisk mark means it is downloading. Once it says it is using TensorFlow in the backend, it gives that message. And now let's say x train and y train and x test y test is equal to mnis.load_data. Whatever is readily available, I am just calling it. Now reshape is important. I want to make sure that the data shape is with the index 0, 28 by 28 by 1. It is grayscale one. And train and test both are similar here, and they should allow even decimals also, so that when I do the scaling of operations from 0 to 255, I will bring it down to 0 to 1. It should work float. So it's done. Now what I will also want to check what is the shape I have, and when I check it, it shows me there are 60,000 records, totally 60,000 objects with 28 by 28 by 1. Now I will see what is the shape of the train, y train. Y is the target variable, which is 0 to 9, digits 0 to 9. There are 60,000 objects available, so comma means there is no value, is only one value is present. So it's good. Now I will also check what is the data available until 10th value. Yeah, so when I do that, so all unique values it will appear for me. So I've got the list of all the unique values that are there, and data type is also here. Now this is the target output. Now I will use the utility thing to get the 10-dimensional class matrix. So I am converting the 1-dimensional class array to 10-dimensional class matrices. What this essentially means is, if you have, let's say this is the annexure part. Alright, let's see what is this utilities is doing for me is when I have the values as 0 to 9, 0, 1, 2, 3, 4, 9. So this machine, these are all categorical, this classification, right? These are categorical. So it has to do one hot encoding and say when 0 is there, then it will keep 1, 0, 0, 0, 0 and so on, and becomes 1, a vector like this. And second one is 0, 1, 0, 0, 0, 0. So this way it is unique, and that's how instead of this it creates 9 different columns in fact for the encoding part. So a 1-dimensional class array to 10-dimensional class matrices, it converts the data, or one hot encoding that happens both for the y train and y test. We have done the we have done the split. The machine already has the split available within it. I think 80% is the training and 20% is the test. So we can see the data in the train. So by looking at this, so it is now converted from 0 to 9, which is present when we see what are the unique values, to the unique values appeared as this. First one is all zeros and 1, and then 1 and all zeros, and so on and so forth. So wherever the value is present there, the 1 is appearing. Now, so the shape also, earlier it was 1 and now the shape is 10. So I hope that I have run this encoded thing. Let's quickly go over. Now you can use this matplot library and plot im show, image show, and you can give x train 0.reshape, so it will provide you the shape of that value. Similarly, you can run for more examples are here only to check, but then once you check out another x train 5 and so on. Now in the model architecture, if you see what I have done is inputs is equal to, first thing I have to do is I have to define the shape of the input. Input is another model within this Keras. So here shape is equal to image size 1. Now and then I will, for convenience purpose, probably I will try and break this into multiple cells so that we can easily see. In the second one, what I will do is I will only keep one convolution bit. So let's say I will convert this into a convolution, and now from here this will help for you, so that we will be able to easily go through the data. Now once I have, and then all the dense points I will take to a completely different cell. So here now I have defined the first one, inputs, and then I'm image size is not defined. I will check where the error is coming from. Okay, so well, let me define image size is equal to 28 and we will run that. Image size is equal to 28. Is it 28 now we are working with? Yeah, 28, and let's see if it runs. Now it ran. Now there is another conv2d is not defined. So I think there is this big problem of TensorFlow from 1 to 2. So in TensorFlow 2 you have conv2d available. So if you have updated your machine to TensorFlow 2, you will not have your Kaggle ones also running. If the problem persists for me, if the number of things to be changed are many, then probably I will not run for now. And again another conv2d is not defined, so I will have to execute this. So and let's see if it so I am doing the troubleshooting directly online probably. Yeah, now what I have done here, model, I've identified this model is nothing but conv2d. Conv2d is part of the Keras, where you will see here from layers I have taken conv2d max pool 2d. This is for convolution purpose. Then I also taken for layers import dense to create that dense dropout we spoke about, and activation is used even here where relu is used. We will use in both the cases relu, and at the end we will use softmax because it is multi-class classification. Flatten is another function that we are calling. So we are also starting with sequential model in input. So model is what everything where we are saving. So we have already looked at one hot encoding there. Alright, let's now run the remaining parts. So understand here, filters are 32 filters we have used. Each filter size is 3 by 3. So these are hyperparameters you can choose, and padding is same, there is no padding here, and activation is relu, rectified linear unit, and input shape is nothing but image size comma 1. So this is the input size, and now a model is a function of the inputs that we are taking. Whatever are the inputs here, this inputs we have come. So in the TensorFlow 2 you have to always refer the previous computation here and then add an additional computation before that. So we ran this, and then we have done max pool 2d with a pool size of 2 by 2. It's good. So next one we are doing is we will drop 20% of these connections and flatten it. So again, flatten is not defined, there is a spelling. So this is also built in hurry, while the actual case tomorrow I will show you of German traffic signal tomorrow. So that will be good. Here if you notice there are multiple, so I have flattened this. Now I am going to multiple dense layers, 1 2 3 4. You will notice that the changes that I have brought in also 784 256 then 64. However, we will let us do it faster. Maybe we will have some of them, accuracy may go away. Retain it 1 2 3 4 5. So 4 layers, and fifth one is output. Output is here where you are getting it. Activation is softmax. We don't need to have 43 here. Why do we have 43? It's only 10. So here we don't need to mention. In any case, let me run this, and now once you design your model, then you have to compile the model to check how well it is able to do. Alright, so in the compilation you have used loss is cross entropy, categorical cross entropy. Optimizer is, we have not used gradient descent or stochastic gradient descent. Instead we used Adam. Tomorrow we'll explain the other formats if required here by showing. Metrics is accuracy is allowed in the Keras. So I will run this. So have got, and then I am now fitting the model to check for the current training purpose. I am fitting the model, so it has given some errors. Error when checking expected dense 6 to have shape 43 but got array with shape 10. Yeah, this is where I was wondering, we only have 10. In fact, we don't need even this dense one. So I will delete it. So yeah, so what we can do is, let's say if I'm getting it, I'll have this resolved full input, all inputs to the layer should be tensors. So something is not defined as a tensor. So I will get this rectified probably again, and then we will see what needs to be done. The model is moved into this. Alright, so in terms of the steps to avoid loss of any time, so once we compile it using the optimizer, so we can pass an argument here for each parameter, optimizer parameter, loss parameter, and then metrics which one you want to do, and then fit the model. So once you fit the model, this is where you say whether you want all of them to go at once or you want a batch size. Out of 60,000 we have got, so you can create a batch size and number of epochs, how many times it should run, and whether it should provide the details or not, verbose, it provides details. Then you will evaluate what is the accuracy that you are going to get. So that score you will present it. In this, when I tested, I am getting a score of 98% for the evaluation or the accuracy of the model. We will look into this. I will probably test it early tomorrow morning, or I will just rectify this error and send you this, and I will not hold everybody. And let's take 2 minutes break, and then all the questions and answers we will see, and I will forward this as well as for the German traffic signal. I'll also share the data set which we are going to work through tomorrow. So wait for 2 minutes and then I will go through all the Q&A and start the question and answers. All right, I'm back. I'm trying to look at the questions to see what we have. Okay. So there are a lot of questions. Now, which one we have? Yeah. Says one question is I think the architecture of CNN explained in PPT is something different than actual architecture of CNN. Layers, convolved, max pooling, ReLU will be represented in cubes, sir. Yeah. So yeah, presentation could be anything. Now in the architecture, so what we have is, if this is the original image and this image gets convolved and using a filter, of course a series of filters you use like this. Let's say I present the filters like this, and you then get those as many filters as you have, then the convolved values will appear here. Let's say I am combining the ReLU quashed data within this, and this will then you will use a max pool, and again you will have a slightly smaller size, but then the number of layers or number of maps or features will be similar. This max pool layer will have similar number. So now you are going to flatten this. You can repeat this operation any number of times, and once you flatten it, so then this row and column data one after the other gets flattened. Then if you all the additional ones, they also become flat. So in that image, I think we have adopted that PPT to show you in a detailed manner. Probably the cubes were not mentioned properly, and they have used as slates kind of thing. Yeah. Next one, it doesn't have fully connected layers initially. Will you once look at architecture? This is so fully connected layer is at the end. Fully connected layers are at the end. First, in a convolution, you want to retain this two-dimensional relationship, so you maintain those filters which are the weight matrices you use and slide them through. First one is convolve. You convolve the data and retain the two-dimensional. Then you go to fully connected. Next question is it compulsory to use ReLU in CNN? It depends upon our requirement. We can use ReLU in dense layer. So my experience is that ReLU in the convolution, ReLU in the hidden layers is working well, because you are retaining the entire positive data without changing. So you are retaining that data. And then you also have the negative data is brought to 0 so that you don't miss it. So leaky ReLU or ReLU can be a good intermediate layers activation method. So non-linearity you can bring with that. Then next question is, what is group pooling and concatenation pooling? Yeah, I have not used these terms. Let me check and revert tomorrow. I've used typically average pooling, and max pooling is working well in majority of the time. So let me come back tomorrow on the group pooling and concatenation. How can we apply 32 con filters on 16 max pooling feature vectors? So filters are applied on an image, and the numbers can be any. The question is, how can we apply 32 con filters on 16 max pooling feature vectors? Okay, so the question probably is, once you have here 16 max pool vectors, again how do you go and use 32 con filters? Is this what your question? Probably. So normally first thing is you have an image and then you have filters. Let me see if you are referring to this example and where you saw so many filters being more than the channel. Here the N2 size cannot be there. Normally it is smaller. However, you can run. Okay. Next one. For RGB we can get 3 channels, but in case of skeleton image, how many channels? Skeleton image is gray color, which gray color will have only 1 channel, so single image you will have. A RGB only we will keep initially as this, and then in the filters you will do a dot product of all 3 of them. So next one, the process of dot product changes for 3D images. Actually in convolution the multiplication is followed by addition in 2D images, but in case of 3D in case of 3D is a solid, that's a solid, you have depth also, you have, that is yeah, you are right, it is a very different from. So whatever this question, the process of dot product for 3D images in convolution is the multiplication followed by addition, correct. So it's a multiplication here, all the values, similarly multiplication of all the values and the multiplication of all the values in RGB, and then you add all of them to get your feature extraction map, one value here. Now the depth I am not talking, it is again a completely a different method. Next question, batch normalization is done as the pre-processing step. Because of this we can bring all the pixel values in the same scale, but in case of skeletal image all the pixel values are similar. Then see, if even if it is skeletal, you have the value 0 to 1, then there is a distribution from when 0 is no value, there is, you have 0.1, 0.25 and 0.364 and 0.148. so these are all different values, and 0.869 which is probably close to 230 there, where you can do the batch scaling before in the pre-processing itself, and that clean data you will get, you still have a distribution good enough available. It's just that computationally it is efficient to do the scaling before. How to construct this model line by line? Any help doc you can provide, sir? Line by line model, yeah, I think tomorrow I will share this where the error, I will also share tomorrow to you about let's say the German traffic signals identification. So there I will probably provide every line one convolution and the max pool in another line, etc., so that you can see. If you want a documentation, I will suggest documentation is keras.io. you can go there. I don't know what I'm typing. Yeah, keras.io. Here you can see the documentation. So they will provide, you will have some bit of line by line. However, it also requires some bit of focus to see what each line is talking about. So here again he gives the definition. Model is one definition and he is calling the model here. So we will do our two examples line by line so that at least it gives some heads up. Next question is, what is the need for batch normalization? So you normalize the data so that computationally it is efficient. Next question, please let us know how to construct code using TensorFlow and Keras combination in a model. Request to please give solution for. See, Keras is the easiest one to use, but to use Keras you need to have TensorFlow running in your machine, which is what I am trying to highlight. You got to have TensorFlow running in your machine. So once you do the pip install TensorFlow and pip install Keras, then we will also share with you a documentation on how to install if required. So then automatically once you call the Keras here, once you call keras.models, it is sufficient. Now you are ready. The model is where you have the data, and within this model, if it is ANN, you have dense, dropout, activation. These three. If you are using CNN, then you have con 2D, max pull 2D, flatten. Of course, you also use activation and dropout in convolution also. The CNN also here. Now, see, if you have to use, you have to convert your categorical value, so you will use this utilities function. So simply put, these are the libraries that you got to have. Let's say utilities always, it is almost always required. So these are the libraries you need to, or the functions that you need to call in, and you can do it. TensorFlow you don't need to worry about, only for later flexibility. Instead of writing this code, this is all you are writing in Keras. If you want to directly write in TensorFlow, you can write that too. Or if you want, I shared with you an example where without using any libraries we have coded for a simple gradient descent for 2 input values and 2 output values. You can do that also. So follow the Keras method. You call in these functions from this library or the API that we call. Within that, all these methods you call, and you can write it in 4 or 5 lines itself. Next, if we use dropout rate is equal to 20% in training, then we have to multiply the pixel values in testing with weights and point to? No. Dropout is in a fully connect. The question is, if you are using dropout rate as 20%, then we have in training, then we have to multiply the pixel values in testing with weights and point to no. So dropout is the connections that we have. Let's say the connections that we have here are something like this. I'm hoping my voice is clear for you all and there is no problem with the speed. So, and in the dense connections, so you have all of them are fully connected here. This is what we are saying. So this, when it is fully connected, maybe it is possible that it is overfitting. So therefore you are suggesting that of these connections, drop some connections. That's all. Point 2 is drop 20% of those connections across. So you don't have any impact on changing the predictions during the testing, nothing. From all of this, it will looking at the input and output pattern. Output, what is the pattern I see, and finally what are the weights, what are the parameters that I am getting. So I use these parameters only for testing purpose. That's all. It is a very straightforward thing here. I'm checking for other questions. What is the need of activation functions? What happens if we won't use them? Kindly explain by taking examples. I know it is used to add non-linearity and for normalization purpose, but what it means? Excellent. So the question is, why should we use activation function? Let us take an example of running a model without activation functions. So you have a neuron here. We are saying here you do the sigma, which is connection of all the data, which is, let's say these are x1, x2, x3 values, and you have created some sort of a bias, you have identified some sort of a weight here, weight 1, weight 2, weight 3 and a bias, and you added all of them. So now this value which you have, you want to apply it. So this is as good as your y is equal to mx plus c. This is exactly like that. Now what if this data, when you are from here, it goes to another neuron, right, and then another neuron here, another neuron here, and I'm talking, you don't do any activation. So this data, let us say x3 is minus 40, let's say, and all of this is 4, this is 6, and this is 2, this is 1, this is 4, this is 1. Now what happens is that the moment you have done this mx plus c, you will multiply minus 40 into 1 here, so you will end up getting minus 40 here, and let's say remaining things are all 42. The end result is just 2. Yeah. Or sometimes the end result of this, if the for minus 40 here and this is all become 28, the end result is 12. Now you take this minus 12 like this and then go and add. So what is happening is, then the next values here, there is a good learning, some bit of 6 here, and this is 4 here that you got, but then because here you have already minus, and this minus 40 is affecting here and here, and because it is minus 12 here, this 6, 4, 10 becomes 10 minus 12, the answer is 2 here. So from here to here, the learning is almost negligent with 2, because you are nullifying whatever is the learning that you are getting through sigma. Sigma is nothing but you are trying to learn from multiple values. That learning is getting nullified because of this minus 40. This is the biggest problem if you use just a linear activation. So this y is equal to mx plus c is nothing but a linear activation. Simple linear activation if you do, you have a problem of your minus negating your learning. So therefore you are saying I will bring either a non-linear activation so that I don't lose the data like that because of minuses or anything, or I can use simply, I don't want to take any non-linearity, I want to stay linear only, then you use a rectified linear activation. So in the rectified, any negative becomes 0 so that you don't lose the learning of plus. This is precisely why you use activation. You are using activation where this negative value will not affect your learning that you are getting by way of adding these numbers. You should not lose that. That's how you are still using in a ReLU is nothing but simply your linear activation, linear method only. Whatever is the input should go just as is, but then a small change that it is doing is I am rectifying minuses into 0. So this is recommended, and hope this clarifies. Next is, since CNN takes features automatically, can we define add our own con filters features? See, feature filters are nothing but your weight matrix. So this is your weight matrix. So the weight matrix means you have W1 to W9 weights. These weights initially you give as an initializer only, maybe all zeros or all ones, you will give some value. Then you will allow machine to go forward pass and backward pass. We said error rectification. During error rectification, the weights get changed. The weights only will change. It doesn't change the input values. So finally, you will get a new data which is final set of weights. To answer this question, since CNN takes features automatically, can we define or add our own conv filters? So here you give a default value or unified initializer, and finally you get a weight. There is also pre-trained models for faces, for object detection, etc. In the pre-trained model, you have this weight matrix fed here initially itself, so that it will try and recognize. You don't have to do much of, then you only strengthen by adding one or two more layers if you have some unique data of yours and which has to learn from it. So pre-trained model, it is possible. Is there any rule or specific reason to fix the number of hidden layers in CNN or NM? No, hidden layers is to get more and more combinations of weights. So you get more parameters. That's how hidden layers. So there is possibility that through the combinations you may learn better, is the idea. Images are of three types: color, gray and black and white. Gray matrix you are talking about is for black and white images consisting of matrix of ones and zeros. Yeah, gray I mean black and white only. So gray scale we say, where it will only have that light intensity of from 0 to 255. So you can have 50, 100 etc., which is gray. Fully black is a complete white, etc. white. So because all three colors are combined there, but strictly speaking, only the gray scaled light effect is observed there. So these are not three types, these are only two types that from the machine standpoint. Next question is, what is the criteria to decide the stride value and filter size? Recommended dropout fraction. Excellent question. So my understanding, the question is, what criteria will decide what stride? So stride we can use in both convolution time as well as in the pooling time. So striding is how much of jump we should have, how much of transition we should have when we are using a filter here. Similarly here, how much of movement I should have when I am creating a max pool. See, typically this is trial and error method. I would say this is trial and error method. You use the stride of 1, but if you think it is computationally super going, then increase the stride to 2. If you have too many cells, you have not downsized. Typically 1000 by 800 image we downsize and bring it to, let's say, 32 or 64 maximum. 64 by 64. That image, if you take 64 by 64 pixel, clarity will be very poor. Now in this case I want to retain stride 1 only, I want to capture every data. But if it is very sparse data, very dense high pixel image, then I would suggest you can go for a stride 2 or stride 2 maybe you could go for. Next question here itself is filter size. Filter size standard is 3 by 3, but again use the same logic. If you have very sparse data and very large data, use a filter of 5 by 5. The recommended practice is follow this 1 or 3 or 5 or 7 people don't use. This is the recommended. Final question I have here, X train and X test, Y train and Y test, is it predefined variables? Yeah, you have to look at. There is a full data set, a basket, or I'll put it as a basket of values. These are all different numbers that you have. Now when you have this data, now each data has a label also. So these are all, let's say, MNIST, and the label is there. Label is what is the name of that number. Let's say these are all the images of animals. So a image you take, this is image, and then that image also has a label. The label of the image is in the first case, let's say this is dog, and then this is the another image, and this is image X, and this name is tiger. Let's say these are all the images that you have. Now we call these images as input variables, X input variables, and this is a Y target variable, what we want to predict or something, Y. So in the X train, Y train, or X test, Y test, X is nothing but input values, the input values, Y is nothing but the target value. Now what we have done is, in this we have taken a small portion, this small portion, and said this I am keeping it aside, and I will train my machine only with the remaining things. Only this remaining 80% I am training my model to generate for me a set of parameters. So this 80% set is called training set, and then the 20% which you kept for evaluation purpose, this is called testing set. Now both training and testing of X have similar composition, but then the pixel, different pixel lengths will be there. Similarly, Y, both train and test are same, they are target values which are labels, however the labels can be different. So that's how the split is made, so that X test and Y test are the images and the labels which you want to use for the testing purpose. X train and Y train are the images that you want for training or learning purpose to generate a set of parameters. Parameters are nothing but some W and B, Wn and Bn, so or Bj we will call. So because the number of weights will be very high compared to the number of bias terms that you bring in every computation. Alright, so I think I have the questions that I've got done. Tomorrow we will do two important things, very important tomorrow. One, we will run the German traffic signals image, and we will go through. I will also convert all the algorithm into line wise will do. I will also get you a link of this German traffic signal data set if I can provide, so that you can try by yourself. Thank you for taking out time, and look forward tomorrow to execute this. I'll have this shared through Blsckbuck-Anurag University leadership, these mails to you, so that you can access them.